In this video, I will start section 4, rate of change. The first part of rate of change is horizontal motion. So in this video, we will be talking about position, velocity, and acceleration. The position will be represented by st, and velocity will be represented by vt. We will be talking about two types of velocity: instantaneous velocity, where we take the derivative of the position function, and the other one is average velocity, where we take the change in position divided by change in time, which is st2 minus st1 over t2 minus t1. So the same goes for the acceleration. We will be talking about two types of acceleration: instantaneous acceleration, where it is the derivative of the velocity, in other words, second derivative of position function. And about average acceleration, it is change in velocity over change in time, vt2 minus vt1 over t2 minus t1. So there's a typing mistake here. It's supposed to be a. Alright, there are some notes we need to know to understand the questions. If the question says the particle moves to the right, it means the velocity is positive. If the particle, an object, moves to the left, it means the velocity is negative. Here velocity is positive, here in this situation velocity is negative. And if the question says the particle, the object, stops or at the rest, then we will understand that velocity is 0. And when we are given the period, the question will tell us to find velocity or acceleration during first some seconds. So it means t1 is 0, t2 is that given number. Okay, let's start solving questions. First question in your book. A point moves on the x-axis. The function st is t squared minus 5t plus 4 in the position function of this point. T is measured in seconds and s in meters. The first question: find the average velocity of this point during the first 2 seconds. First 2 seconds means t1 being 0, t2 being 2. So what is average velocity? Average velocity is delta s over delta t. Okay, let's start solving the question. So average velocity is delta s over delta t. So what is delta s? It is s t2, which is 2, minus s t1, 0, over t2, which is 2, minus t1, which is 0. So substitute 2 for t in the function. The function was t squared minus 5t plus 4, right? So it's going to be, plug in 2 for t, 2 squared minus 5 times 2 plus 4 minus. Now plug in 0 for t, 0 squared minus 5 times 0 plus 4, all over 2 minus 0. So here I have negative 2, here negative 4 divided by 2, negative 6 over 2, which is negative 3. The unit is meter per second. So that's how we found average velocity. Part B. It's asking about its instantaneous velocity. When it is instantaneous velocity, we just take the derivative. Instantaneous velocity means rate of change of the position function. So we just take the first derivative of the position function to find the velocity at the given point. So part B, this was A, part B. So the velocity function is equal to first derivative of position function, which is derivative of t squared is 2t, minus derivative of 5t is 5, derivative of 4 is 0. So this is our velocity. We are looking for velocity at 2. So we just insert 2 for a t. 2 times 2, 4. 4 minus 5, negative 1. That's negative 1 meter per seconds. Now, part C. Part C is asking about average velocity during this period from 3 to 7. Like the first part, our T1 is given as 3, t2 is given as 7. So average velocity is change in position over change in time. So change in position is as 7 minus as 3. Change in time is 7 minus 3. Substituting 7 for t will give us 7 squared minus 5 times 7 plus 4 minus, replace your t's with 3, it becomes 3 squared minus 5 times 3 plus 4 all over 7 minus 3, which is 4. So let's calculate this part, calculate that part, subtract from each other. We will get 5. So it is 5 meter per second. All right. Let's continue with part D. Another check it out question. What is its instantaneous velocity at t is equal to 5? Like part B, to find instantaneous velocity, we just need to take derivative of position function. We find v function, which we already found it in part B as 2t minus 5. So we need to find this velocity at 5. So 2 times 5, 10. 10 minus 5, 5 meter per seconds will give us instantaneous velocity. Part E, find acceleration. It doesn't say average or instantaneous. So we're just going to take derivative of velocity to find acceleration since it doesn't mention average. So at t is equal to 5, we are going to find instantaneous acceleration. So what is acceleration? So acceleration function can be found by taking derivative of velocity function or by taking second derivative of position function. So the velocity function was 2t minus 5. Just take its derivative, which is 2. We are looking for acceleration at 5. So no matter what rt is, since the result is constant, it is 2. So 2 meter per second squared this time. Okay, last part is asking about average acceleration between two instants, 3 and 7. Okay, average acceleration is change in velocity divided by change in time. Change in velocity, v7 minus v3 over 7 minus 3. Let's substitute 7 for v first. So 2 by 7 minus 5 minus, substitute 3 first for t. 2 by 3 minus 5 over 7 minus 3. Let's do the calculations. Okay, subtract this part from that part, divide by 4. We will get 2. 2 meter per second squared will be the average acceleration between those two instants. Okay, we are done with first types of questions that you may face. Second, okay, still the same type. It is a ministry question and an exercise question from the third section. It was supposed to be here, but they asked this question in the previous section. We are given the velocity. We are asked to find the velocity and acceleration at t is equal to 3. So velocity function is already given. So we are not finding anything. Function is already given. We will just evaluate the function at 3. So switch your t with 3. So 3 squared 9. 36 minus 9 is 27 meter per seconds. So this is the first part. I am done with finding velocity. What about acceleration? Acceleration means first derivative of velocity, which is negative 2t. I got the derivative, I got my acceleration function. Now I'm going to evaluate this acceleration at t is equal to 3. So negative 2 by 3, negative 6 meter per second squared will give us the acceleration. Okay, let's continue with another type. An object moves according to the position function. At what time its velocity be zero? Test prep question. We want our velocity to be zero. So how do you find velocity? One position function is given. You find velocity by taking the derivative of position function, which is, in this case, cosine t. So we want our velocity to be zero. So when cosine function is equal to zero, what's the angle? Angle is pi over 2 plus n pi, where n is an integer. You can use that idea. You can give some values to n, like let n be 0. Then what will t be? 0 plus pi over 2, option C. Or we don't have to do it in this way. We can just try options. If we try options, how does it work? Substitute 0 for t in the derivative. Cosine 0 is 1. It is not your answer. We are looking for 0 at the end. Cosine pi, negative 1, not the answer. Cosine 3 pi over 4, negative square root 2 over 2, not the answer. Pi over 4 gives you square root of 2, not the answer. Pi over 2 gives you 0. So this is the answer. Either by solving or trying options, you'll find the answer. Okay, another type of question. This type came in Vezari once, and it's an exercises part in Kurdish edition. It was in English book before, but it's removed. Now it's in Kurdish book. We are given the position function. We are asked to find acceleration where velocity is 0. So we are going to find our velocity first, equalize it to 0. When we equalize the velocity to 0, we will find t's. After we find t, we will put t back in the acceleration. Okay, let's find the velocity first. So velocity is derivative of position function, which is in this case 3t squared minus 12t plus 9. I see a common factor. 3, take 3 out. T squared minus 4t plus 3, which is supposed to be equal to 0. Equalize it to 0. So since I see a quadratic equation, I need to factorize it. T, 3, 1. The middle term is minus, so they are both minus. T minus 1. T minus 3 is 0. So t is either 1 or 3. So I have two possibilities for t. I got my t's. Now I need acceleration. So you know how to get acceleration. You find it by taking first derivative of velocity. What was velocity function? 3t squared minus 12t plus 9. Take its derivative. It becomes 6t minus 12. Now I got my acceleration function. I know my times. Now I will find two different answers. One by one, try each t. When t is equal to 1, what is your acceleration? 6 times 1 minus 12 minus 6. When t is equal to 3, what is your acceleration? The same function. 6 by 3 minus 12, 6 meter per second squared. Okay, these are the answers. Okay, another type of question. Test prep questions. A particle moves on the x-axis with this position function. The question is asking about what time will the point move to the left. A point being moved to the left means its velocity being less than 0. So find the velocity function, set this less than 0. What is velocity function? Velocity is derivative of position, which is 7 minus 2t. So set this less than 0. In this case, move negative 2t to the other side and divide both sides by 2. 7 over 2 is less than t, or t is more than 7 over 2. So in which option we have a number more than 7 over 2? This is 3.5. Which one is more than 3.5? 4 is more than 3.5. So this is the answer. The next test prep question is asking about the time where the point stop. When the point stop, What happens to the velocity? Velocity becomes 0. So just equalize the velocity to 0. What was the velocity? 7 minus 2t. We already found it. You set 7 minus 2t to 0, which makes t 7 over 2. Option C. Alright, so we solved every type of question about horizontal motion.